Alright, so in the previous video we actually discussed about the low pass filter where we sub in our S as an analog frequency. Alright, so now we're gonna sub in our S as our digital one. Okay, so I'll just take this A over S plus A, I'll just put it over here. Okay, and then instead of going through all these processes, alright, I'll just leave it here first. Okay, later on we will still get back the same answer because this equation over here, this A over S plus A, is directly equals to this thing because of this conversion, you see. Or in other words, this thing is equals to this thing after we convert this. If you still remember, this one is equals to 1. So I'll just simply rearranging into this form. So in this video, we will not rearrange it, but we'll just keep it at this state where we sub in our S. What do we sub in as our S? We sub in as our trapezoidal equation, 2z minus 1 this thing. Alright, so I'll just sub in as this thing all over here. Okay, so to define more clearly, this is this form. Okay, so what can we do next? My purpose over here is that if I were to sub in z is equals to e j omega t. Okay, because if you still remember in the previous video we defined that this thing over here is a digital frequency, this omega is a digital frequency. So if I, instead of subbing in frequency, this is the analog frequency equals to 1, so if I were to sub in my digital frequency as equals to 1, okay, because we know that S is equals to j omega, so if omega is at the S domain is stable, alright, it's somewhere over here, or just over here because it's frequency, this is still stable, although this is marginally stable, but at least it's over here, it's still in the left half plane, right? So therefore, in such of the case that happen, when you plot it inside the z domain, it should be somewhere over this side, you see, along the semicircle, I don't know where lah, but yeah, I think you get what I mean, right? So with the same value of frequency, alright, this is inside the digital frequency, this is inside the analog frequency. With the same value of frequency, we'll harvest different outcome, and therefore this is the purpose of this video. So if I were to sub in this frequency as equals to 1, alright, which is same as this analog frequency. So I repeat again, this is analog frequency, this is digital frequency, but frequency is just frequency, right? But however, due to this phenomenon, it will cause your value at the outcome over here eventually will have certain values that is slightly different from our outcome over here. Our outcome is actually 0.9, if you still remember. After I sub in my omega as 1, I sub in my current frequency as 3. After that, I calculate this whole transfer function as equals to 0.9. Okay. However, in this videos I actually calculated, later on I think you will have 0.8. Okay, 0.8, sorry, yeah. So we have slightly distortion that occurs. So how does this distortion comes in is the purpose of this video, to explain where is it the problem that lies on it. So hang on tight and let's carry on. This is where we last stop before I go and rumble onto something else. Alright, so now I just sub in this thing as my z over here. Okay, so if I were to sub in into here, I have this thing. Okay, so this thing I rewrite as this thing. Okay, most probably this one. I sub in the z as this equation over here. Okay, I don't sub in my frequency yet. Later on I'll just sub in. I'll just leave it as the general equation first. Okay, because I want to derive the general equation also. Alright, the equation will be pretty much important for you to understand. So let's just continue. I can rearrange this thing by something else. What is the something else? Is this thing. Okay, I can multiply this. Alright, what is this difference between this is that this one is everything divided by 2. Okay, and you may wonder what is this meaning, and because I think it somewhat links to your Nyquist frequency. If you still remember your Nyquist, I think I haven't said yet, but the Nyquist frequency is pi over t, where it comes from your 2 pi over t, alright, which is equals to your frequency or your omega. Alright, however, because you know that due to alliancing or whatever thing, or there's some distortion that occurs, alright, the overall your omega is actually pi over t, or in other words your omega over 2 is equals to pi over t. Okay, so normally you need to times 2 in order to to get back to your original signal, something like that lah. Okay, so over here this is omega over 2 when it is equals to pi over t. Alright, if I were to switch, instead of I switch to pi and omega, I would have what? I will have omega, pi over omega is equals to t over 2 also. See, omega over 2, t over 2. So this is where we sub in as omega times t over 2 for whatever it is the reason. Something of the meaning, okay? I'll leave you to think about it in the future. But this is, I think, is linked to that. So therefore we multiply with this thing. Okay? Alright, so let's continue first lah, okay? And this thing over here, why do we multiply? It's because I'm only rearranging. I didn't change anything. This one is equals to 1. Alright, I'm only rearranging this within itself. Okay? And the purpose is to show you something later on. Okay, so I have a over 2 over t. Okay, this thing times this thing, what do you have? Alright, you have ej omega t multiplied by e minus j omega t over 2. When you multiply, alright, the exponential adds up. So it's like j omega t minus j omega t over 2. So what you have is j omega t over 2. Okay? And therefore what I will have for this thing multiplied with this thing, I'll have e j omega t over 2. Okay? I think you understand what I mean. I'll just simply multiply. Because of the exponential, they add up together. I'll have this form over here. And then minus 1 times this thing equals to your this thing. It's just, yeah, minus ej over 2. Okay? And then divided by same thing, this thing multiplied by this thing, I'll have the same thing as this lah. Okay, so I have this and minus, so not minus, plus now because it's plus 1 times this thing. Alright, right, I'll have this thing and then plus a. Okay, so I'll rewrite this thing as this thing. It's still the same. Alright, it's still all the way, if you come back, it's still this thing. Okay, this thing is where I sub in my z as my this thing over here, and then I'm rearranging the whole equation, alright, by multiplying this thing over here, and then I switch it to here now. Okay, hope that this is pretty clear. Now I can also further simplify this whole chunk. How can I simplify this? Okay, if you still remember, ej theta is equals to your cosine theta plus your j sine theta. If it's e minus j theta is equals to cosine theta minus j sine theta, or your Euler's formula. So I'm going to utilize these definitions to somewhat rearrange this whole thing over here, which is very hairy lah. Alright, so in order to do that, I'll just sub in wt over 2, alright, as equals to x. There's no meaning in there. There's totally no meaning why I sub in. The only meaning that I want to say is that I'm lazy to write, so therefore I just sub this thing as x. Alright, so I have ejx is equals to cosine x plus j sine x. Because I'm lazy to write omega t over 2 in here, I can also write omega t over 2 in here. Alright, but because I'm lazy, because I have one term over here, I need to write this thing. If 2 terms, I need to write times 2 of, I need to write a lot of things. So for simplicity's sake, I'll just write as jx first. Okay, because I just want to convey the meaning to you. So in order to convey the meaning to you, here's it is. Okay, so this term over here I can rewrite as this thing. Alright, where your x is, remember this thing over here is your x. Okay, by simply using the Euler's formula, I just simply subbing in only. So this thing over here I subbing as this, then this thing over here I subbing as this. Same thing for the bottom, this thing over here subbing as this thing over here subbing as this. Okay, so I hope that you are pretty clear with this now. Alright, so then I'll just simply solve for this. Okay, later on we'll see the outcome. Alright, so I carry on first. So this cosine x minus cosine x, I will have nothing, right? So I'll just leave it as nothing first. And then j sine x minus j sine x, I'll have, so j sine x minus is plus, so plus j sine x. I have 2j sine x. Okay, and then cosine x this is plus, because this term over here, this thing over here is plus. Okay, the denominator is plus. Okay, I forgot. Oh yeah, anyway, So over here I'll have cosine x plus cosine x, I'll have 2 cosine x. Alright, where j sine x minus j sine x will be 0 lah. Okay, so what can I deduce from this is that if you still remember your trigonometry rule, your sine is equals to O over h. Alright, your tuakaso thing. Alright, so therefore I have O over h for your sine divided by, for cosine is A over h. You still remember? So therefore if I were to cancel out, I will have O over A. O over is what? Is tangent. Right, so therefore what we have is tangent xj. Okay, where these two also cancel each other lah. Only thing is that the j is over here lah. Okay, so my sine x over cosine x becomes tangent x. 2 and 2 cancel, the j will carry on with it. So therefore I have a j tangent x over here, where x is your omega t over 2. Okay, because I lazy to write, this is why I just simply write as x. Alright, so with this definition, this understanding, I can simply sub into this equation. Alright, so this thing over here can be simplified into what? I would have this thing over here written as this one, tangent omega t over 2, where omega t over 2 you know that is x, right? We have told you that. Okay, so yeah, so after a long chunk of stuff, we can also say that this thing over here is still your s, right? Because it's a over s plus a, your low pass filter. But firstly, we sub in our s as a trapezoidal, the bilinear or twisting, whatever, they're all the same thing. Alright, so this thing over here is your s lah. Okay, so therefore if you were to head back to the previous one, over here we actually rearrange these things, right, by multiplying this. So now I can rearrange things so that you find it fairly clear for you. Okay, so I have 1 over a divided by 1 over a also. Alright, if equals to a times 1 over a, I have 1. Alright, and then this thing times 1 over a is a huge chunk, right, which is this whole thing over a, and then a times 1 over a, I have 1. Okay, so this thing over here is still 1. I will only rearrange this thing using this thing. Okay, it's the same thing as the equation as the previous video. So my form currently right now is the same form as this form. Okay, this thing is still your s. Okay, same thing over here, this is your s over here. Okay, so I hope that this is pretty clear. And because we are looking at the magnitude of the frequency, because this frequency can maybe a positive one and can be this whole thing may over here can be negative or whatever. Alright, so we only want to look at the positive one, so I'll just simply square them all together. So what I will have is, I would have these things all over here. Okay, so I'll just simply squaring them all together. Okay, so now what can we do here? Okay, if you still remember our condition, alright, we sub in as my a is equals to 3 and my capital omega is equals to 1. Alright, this capital omega what is your analog frequency, right? It's an analog frequency. So I'll just simply paste these definitions so that you understand what I mean. So I put it over here. Okay, so in this case I would use the same frequency. This is my digital frequency, I set it as 1. Where my period, I'll just set it as 1 also. If you set it as 2, set it as 3, in the end you'll still have nothing that influence this equation. Alright, later on the t will cancel each other in any ways. Alright, but I'll not go into the details of the math, but I'll just simply sub it as 1 for simplicity's sake. Okay, if you sub it as 2, you can sub it as 3, whatever, you'll get the same outcome. But I'll just sub it as t equals to 1, that's all. Okay, so with these conditions, alright, what can I do with this? Alright, I can simply sub in as, so I'll just copy hold on. So I'll just put in my conditions now, alright? So my t is equals to 1, so I'll just switch my t is equals to 1 first. Okay, so I have 1 and 1 over here. Alright, I know that my frequency is also equals to 1, right? You just take a look in the picture. Okay, so I'll just sub in as 1 also. So 1 times 1 is still equals to 1. Alright, and then this j is simply just telling you that it's imaginary, nothing much information carry on with it. Okay, so I'll just leave it there first. Okay, next, my A is equals to 3, right? So I can just simply sub in my A as equals to 3. Alright, so now I can evaluate this whole equation. Okay, if I were to sub in inside the calculator, what I would have is, so if you want to sub in the calculator also for yourself, you can just type in this thing, alright, 2/3 times 10 to the power of half, alright, to the power about 2/3 times tangent half, sorry. And therefore if I were to evaluate this one, I'll have 0.364, okay, and then if I were to solve for this, alright, I'll have 0.88. Okay, comparatively this is 0.88. If it's in the analog frequency, this is 0.9. Clearly there is some discrepancy. Okay, this is when we're only looking at low frequency, when omega is equals to 1. Okay, so with this low frequency, alright, we can somewhat see that there is a problem already. Slight problem, 0.88. So the higher frequency we go, the more problem we will have. Okay, so the more distortion we will have for this value. And therefore this is the distortion between the frequency, because if you take a look, our if you still remember, this is your analog frequency, this is your digital frequency. By right, but with the same frequency we can get the same outcome. Because of the issues with the tangent, think about it, because of the issue of the tangent, alright, there is certain problem with it such that it causes your thing to go a slightly different meaning. You have a slightly different values, alright, and therefore this is called a distortion. Alright, so if you want to know more about the tangent, alright, for this case, then in the next video we'll discuss more into details of that, because I think it's also related to what you have studied or what you need to study also. So yeah, in the next video we'll actually go into more details of why the tangent stuff actually distort our signal. Alright, so see you there.